Very nice. What is part 2? Sadly, a shrine of this shape would be neither original nor impressive compared to its height. One of the knights proposes that only the thickness of the layers needs to be changed. The idea involves generating the layer's thickness recursively. It sounds like something worthy of the glory of the god of the lost. So I guess null pointer is the god of the lost. Did they say that up there? I just missed it. Yeah, protector of the lost. Okay. I just forgot. Starting with the layer thickness of 1. Start with the layer thickness of 1 and calculate the thickness of the subsequent layers as follows. Multiply the thickness of the previous layer by the current number of priests of null pointer. Your notes. Take the remainder of dividing the result by the number of current priest acolytes, 1111. Okay, so that's going to be the same for everyone. Okay. You have the thickness of the subsequent layer ready to use. Marble is proposed as a material of which the priests have large supply, totaling 2024,000 blocks, however many that is. 20 million? 20,240,000. Okay. The king will, of course, still fulfill his promise to order additional blocks to complete the build, so your task essentially remains unchanged. Really? Seems a little different. You're counting the priests of the god null pointer, noting down the total number and starting calculations of the king's expenses. The final answer is still a multiplication of the number of blocks needed to complete the last layer by the final width of the shrine. Example based on the following notes 3. Assuming only 3 priests of null pointer. All right, so I don't have the number of blocks in my thing. I have the number of priests. The number of blocks is fixed for everyone, and the number of acolytes is fixed for everyone. All right. So if my download has 3 in it, 5 priest acolytes for simplicity instead of the actual number 1111, and 50 blocks are available. Okay. So the test code is going to be 3, 5, and 50, and we do it this way. Example construction plan with layered blocks marked by numbers looks like this. Wait a minute, what's this? The calculation of thickness would be as follows. All right, so multiply the thickness of the previous layer, 1, by the number of priests. So we have 3 priests, so we multiply 1 by 3. We then mod by 5, which is the number of acolytes, right? And then we get the thickness of the next layer. And then this thickness is 3, so we multiply that by 3, mod 5 gives us the thickness of the next layer. Okay, so it's going to be different for each one. And then each layer we do adds another 2 columns. I'm trying to think of how to simplify this, because we're going to have to loop over everything, right? And then once we hit the number of blocks, we have 50 blocks available. Once we go over that, then we calculate how many more blocks we need, multiply that by the final width, and we get, in this case, we get 27. Okay. All right, so this, I think we could just loop, write a little loop. This one's 3 bytes long. Okay. $446. I don't have anything going, right? Okay. So let's grab this. Change the 1 to a 2. Let priests is equal to lines of 0. I guess we can use 64 again. Bars unwrap. Make sure we got 446. Yep. Okay, so now we can loop. We start with 1. Actually, you know, what we should do is make this a struct, right? So this is a struct pyramid, and then we can have priests, acolytes, and that way I can write a test for it, and blocks. Because this is going to be let pyramid is equal to pyramid priests acolytes is 1111, and then blocks is let's copy paste that. Copied, paste. Okay, and I could just print it out as soon as I add the debug to it. So that should give us that. We can see it right here. We can get rid of this line now. And then we'll write a little test. Test mod. Test. Test part 2. So we're going to create a new pyramid. Let pyramid is equal to pyramid with priests of, how many was it? 3? 3 priests. Acolytes are 5. And the blocks are going to be 50. Oops. Is that going to stay on one line? No, it won't. Dang. Okay, and then we could just say assert EQ 27. Should we break it down into 2 different steps? I think we should. Because we can calculate the max. It would be nice to be able to do that. But if we're calculating the max blocks, we already have the width as we're looping over it. So we might as well just do it. Pyramid solve. Right? And there's no solve, so let's generate solve. Inline macro, that's not what I want to do. I can do that here. Maybe I can do it here. Part 2 is equal to this pyramid solve. Now can I create, no, it still says inline macro. All right. Impl pyramid, fn solve, self, u64, 0. Right. And now I can hit test, and we get right, left is 0 is 27, right is 0. Okay. So now we can loop over this. Start with layer, thickness 1. I guess we're going to sum up all the blocks per layer. We start with 1, and then we can go to 2. So our next, we can say while sum is less than self blocks. Right, and that way we'll end as soon as we're done. We can calculate the new thickness. Let thickness is equal to, it's going to be the number of priests. No, number of previous blocks, previous layers blocks. Okay, so we need to save that. Let mut prev is equal to 1. So previous times self priests mod the number of acolytes. Oh, we need to know, yeah, the width of the base. Let mut base width is equal to 1. We're going to add 2 to the base, right? 1 for each side, because the first one is 1, next is 3, then 5, 7, 9, and so on. And now we're going to multiply the width times the thickness to add to the sum. Sum plus equals width times thickness. Right? And that's all we need to do. And then save the previous thickness. And loop again. And then we're going to return the width that we ended up with multiplied by the blocks that we're missing. So the number of blocks we have is here. So it's going to be sum minus self blocks. And hopefully that's a positive number. And that test passes. All right. This might be a very fast, well, depending on part 3, right? This could be a very quick stream. Let's hit run. Oops. Hit E. Yeah, so we got this as our final answer. Let's see if it's correct. That's some quacking genius. Look at that. Okay. Clippy. Clippy's good. git commit -am part 2. I'm getting scared now. Those are two very easy parts. What's part 3?